Okay, so I'm going to set up another example for you, but let's review some of the stuff that we did in the last video. Okay, so we were looking for find the forces, and I should also put up here and the um, angle. Okay, otherwise we don't get a vector. But primarily we took this force f of x and f of y and the vector force of 200 with the unknown angle. Okay, and we're able to figure out what the components are of f of x and f of y, and then we can write the equation in terms of the vector for f of y. We found the angle and we found the force vector. It was given to us as 200, but the component vectors add up into that. Okay, so let's try a different one, and let's see if we can find a whole lot more about things from a different point of view. Okay, and you know what? I got to get the ruler out anyways. I might as well use it to my advantage. Okay. I think this is example 3. I don't think I labeled the last one, but it is what it is. Okay. And this one is if we know the component forces and we want to know the force F and the angle. Okay. All right, so let's do this one, and I'm going to do this one so it's actually working into the second quadrant, so you can have some experience with that too. All right, and I'm looking for that and this. Okay, and that one is f of y, and that's going to be equal to 300 newtons. And this one's going to be f of x, and this is going to be equal to 250 newtons, didn't I? Yep. Okay. All right, so someplace out here, I'm going to do this one in green just so you get the hang of this. Someplace out here is my force vector, and I got some angle that's going to come from over here to there, and I'll use theta for this one. X is out there. Let's get rid of that. Let's go back to black. Let's put X there, put my Y up there so we can just keep track of stuff. All right, and because this f of x is in the second quadrant, this would actually be negative. So you can write that in there now. You can write this in as positive. It'll help keep track of a few things. Okay, so the very interesting one of this is most of this is just some simple math. Okay, so we have a triangle that's set up here. So if we want to find the angle, and we'll use tangent. Okay, so tangent of theta is equal to fy over fx. basically opposite over adjacent. Okay, so Fy would be this piece here, and from this angle in here, that would be opposite, and this one is adjacent. Okay, just so you can keep track of that stuff. Now, the interesting part about this, and I will do my math vertically instead of horizontally, we are 300 newtons minus the 250 newtons. Okay, and that's going to give us an answer of negative 1.2. And literally, theta is equal to arctangent of 1.2, or 50.19. Whoops, sorry. Ain't that fun? I got myself carried away here. Let's do alpha. The reason I was trying to do that, and my alpha is this angle in here. Okay, theta is what I really want to define, but alpha is what I'm looking for here. Sorry, don't mean to mess up the world. Otherwise, it'd be kind of weird. But the alpha, the inner angle, is 50.19. Remember, we want to define it from the x-axis as the positive counterclockwise direction from the 0 x-axis. All right. So in order to find that, theta is equal to 180 degrees minus alpha, or 180 degrees minus 50.19 degrees, and that will be equal to 129.8 degrees. Okay, so that's an answer. And I should point out, as long as we're going along the way here, when you come to an answer, underscore it. If we're working on comp paper, we will have a bar out here to the right, and what we do is 129.8 degrees, underline it, and put over in this side of the page theta, and that will give us a quick reference to that. And I may do a video on that one of these days just to show you how things are going. All right, so what's left is we know theta is now 180 degrees. Oops, not 180 degrees, 129.8 degrees. Let's find what F is and get that defined. So it's relatively simple, and you've probably guessed we're going to use this. Okay, so all that math you learned will come in handy, and that's Pythagorean's theorem, and basically c squared is equal to a squared plus b squared, and where you substitute f's and stuff in for a, b, and c. Okay, and we're going to look at the square root of 250 squared. Yeah, it is negative. Let's get that a little nicer in there. But you're going to find out you square a negative, you get positive. Times 300. And you know what else? Let me redo this. I'm not completely happy. 250 newtons. And when you're done, you're going to get 390.5 newtons, or in three significant figures, 291 or 391. Okay, and that's an answer. And then you go over here and write 391 newtons, underscore it, and of course this line comes down a little further, and you can write this. All right, now simple math, wasn't overly complicated, but it depends on the approach you're taking and where you're coming from. And those are the ways to find force component vectors, and they're fairly simple. Coming up next is how we do addition of vectors, and I'll save that for another video. And then I'll do a little more on the comp paper stuff here and how to write out answers. So that may be a good video by itself. All right. Have a good day.